Alright, welcome everyone to the next lesson in this series, and in this video we will look at the folder structure for the labs. Now in the previous lesson we looked at how you can provision the lab infrastructure, and once you have that set up you can navigate to the lab folders and use the deploy script to provision the individual labs. In this lesson we will deep dive into the structure of those folders and the files associated in provisioning those labs. Okay. So in my terminal here, I have already deployed the lab infrastructure. I have exec or SSH'd into my EC2 instance. In your case, it could be an EC2 instance of one of your local hosts. And if you have the repo cloned and if you navigate to the Containerlab folder, if you do an ls, this is where you're going to find all the lab folders. Now I'm going to navigate to one of the more complex labs here, lab number 10. And let me do a tree and look at the structure of this folder. Now, all of the folders have a very similar structure, but the files that we deploy or the manifests that we deploy could differ from lab to lab, okay? And to start off, what I'm going to do is expand this folder and look at the deploy script. So you run this script and the script will provision the labs with the respective topologies. You don't have to do anything else. You could follow along the lab guide once your lab has spun up. But let's look at the individual files that are involved in provisioning this so that you could make your own customizations as well to these lab topologies. Now, the first thing that the script does is it imports the Arista CEOS image. We're using this image as a switch/router. And in the previous lesson, we looked at how you have to download this image and import it to your local repository. And when you spin up the lab infrastructure, that previous deploy script will copy this image to your host, and the deploy scripts in the respective lab folders will first import this as a Docker image so that it can be used inside Containerlabs. Next, this lab script will provision the Containerlabs topology. If it's already provisioned, it's going to destroy it first and then re-provision the Containerlabs topology. And the topology file in this case is topology.clab.yaml. So next, I'm going to open the topology file. Now, this is a more complex topology. Some of the other labs have a relatively easier or simpler topology, but let's look at this one because it gives you a good baseline. In this topology file, we are deploying a couple of nodes. So the first one here is the Arista CEOS image. We're going to call it CEOS01, and we're deploying one instance of it, and we're also providing it a startup configuration. So when the image comes up or the container comes up, it's going to come up with the configuration file that we've specified for this image. So in this folder, if I look at the startup configs folder, this is where I have the startup configuration for that Arista CEOS image. Okay, so startup configs, there's a file here, which is an input for this image. Next, we are going to deploy a Kine cluster. And for the Kine cluster, we're giving a startup config as well. The file name here is K01, no CNI. So if I go to my lab folder, you're going to find the Kine startup config over here. And if you look at this config, we are deploying the Kine cluster. We are disabling the default CNI, and that's because we will be installing Calico CNI on these clusters. And in provisioning the cluster, we've also specified certain attributes. For example, for the control node, we've given some labels, right? We've specified the node IP. We've done the same thing for the worker nodes as well. Like for example, you can see that these nodes have labels depending on which VLANs they are deployed in the respective labs. You need not worry about the details right now. We will look at this during the respective lessons. Okay, but this is the file for the Kine cluster. So if I go back to the deploy script, so next, once the Kine cluster is deployed, the script will retrieve the kubeconfig file, and it will first install Calico Cuttle, which is a CLI utility that we will use in our lessons. And then it will log in or use the kubeconfig file to install Calico CNI on these Kine clusters. Now, if you're interested in the steps to install Calico CNI, you can look at the Calico open source documentation. In this case, we're using version 3.30, and you could modify the deploy scripts to install other versions as well. Okay. And once Calico CNI is installed, it's going to go through a few steps here. Once it is successful, the install script will then apply any further manifests that are required for this lab. So in this case, this lab is to do with Calico and BGP. So it's applying a few BGP configuration and BGP peer manifests, as well as a load balancer IP pool. Now you need not worry about the manifests that are applied here. We look at these in the respective lessons, okay? But what you need to note is if there are any manifests that are specified in the manifest folder, or if there are any tools that are specified, these will be applied by the deploy script, okay? And that's pretty much it for the script. It's gonna apply them, make sure they were successful, and then it'll spit out the kubeconfig file so that you can access the cluster as well. Now, one thing that I forgot to mention is during the Calico installs, if I go back to the Calico install step, we will be providing what is called a custom resources manifest. And if I open the custom resources manifest, what this is the install parameters or configurations that we provide the Tigera operator so that it can spin up Calico based on the configurations we provide. This tends to change from lab to lab as well, depending on the type of lab. At times, we may have a certain encapsulation mode. We may be doing net outgoing enable, right? So depending on the requirements of the lab, the custom resources that we specify or the parameters we specify for the Calico install differs as well, okay? But that's something I wanted to highlight. Alright, so if I go back to my terminal here, so this is what the structure looks like. Again, we looked at the deploy script. Similar to the deploy script, there's also a destroy script that basically destroys the lab. And then we looked at the topology file, which is basically the Containerlab's topology. That topology file is going to deploy the CEOS image, and this is the startup config for that image, which is basically our router, our switch in this case. It's going to deploy a client cluster, and the startup configuration for the client cluster is over here. And once the cluster is up and running, it's going to install Calico CNI, and it's going to use the custom resources YAML manifest to provide the parameters for Calico CNI. And once the CNI install is complete, it's going to deploy any other manifests that we've provided. For example, in this case, I have a few other manifests for Calico CNI for its BGP configuration, as well as some tools that we will be using to test out the labs, okay? So this is what the structure, looks like. And don't worry about this. In each of the labs, we will be exploring all of the manifests that are applied as part of the lab so that we understand the kind of interworkings between what we've configured and how that is reflected in the lab setup. So yeah, that's it for this video. Hopefully it was beneficial. Thanks for watching. I'll see you in the next one. Bye for now.